Hello, my name is Michael Gaucher, and it is March 25, 2025, and I want to talk about .NET. This is a new channel that I started to talk specifically about Microsoft technologies and .NET. And the reason that I did that is I have another channel where I talked about everything that you can imagine, but I wanted to slice off different topics, and one of those topics is Microsoft. And so my journey with Microsoft began in the late 1980s, early 1990s with BASIC and MS-DOS and so on. But as far as .NET, I learned .NET in 2001, and somewhere around October 2001 to be somewhat more precise. So during that time, I had, like most people, read a lot of my, or got a lot of my information from books from the likes of Wrox Press, because colleges at the time were not teaching these things, right? And so much of my corporate and business software development involved what you call classic ASP, VB script, and Visual Basic, among other technologies, as well as JavaScript. And so Wrox Press was a reputable and reliable conveyor of information about these things. Well, one of the books that they came out with was Beginning VB.NET First Edition. And Beginning VB.NET basically told you a lot about .NET, and you had a book that was published around the same time called Beginning C#, and I was alternating between Beginning C# and Beginning VB.NET, because like many software developers in the Microsoft world at the time, the majority of us used the Visual Basic. In the beginning, we were Visual Basic developers on the Microsoft platform. The C++ developers on the Microsoft platform were doing some very interesting things, but for the most part, they were not building line of business applications. That was more the wheelhouse of the legions of Visual Basic developers. I believe Steve Ballmer estimated that there was somewhere in the neighborhood of about 3 million Visual Basic developers worldwide, somewhere like that. But when they started developing .NET, they wanted to use this language called C#. C# was modeled off of Java. At the time, I was heavily studying Java and Java, what was called Java 2 Enterprise Edition, J2EE. So my mindset was already traveling in that direction. And so if it were not for the introduction of .NET and C#, I would have became a Java developer a long time ago. But I was already experienced in and had much of my background in Microsoft technology. So I said this would be a good transition for me. So I studied Beginning C# and Beginning VB.NET in earnest so that I could come up to speed on these technologies. And so I wanted to be a step ahead on that, because I was one that was, you might call it, an evangelist of new technologies and new ideas. I would build something just for the sake of building it. That's the way I was back then, right? And so the thing is, I got both of these books because I needed to make a decision on, okay, am I going to continue with Visual Basic, or am I going to embrace the new C#, right? It was codenamed Cool, Project Cool, right? And I said, hey, there's a lot going on here. But I like the aspect of how it aligned with Java and C++ in terms of syntax, because that syntax and that way of development, despite the majority of the software development for Windows occurring in Visual Basic in the business world, C++ and Java were still seen at that time as a higher grade, higher caliber way of doing software development. And so there was something about the syntax, the C-style syntax, at least in terms of how we discussed the technologies back then, that made it appear much more structured. Well, it was more structured and much more efficient in how you write code. So it was less verbose. So Visual Basic and the basic light technologies, they were more verbose. You had to use more words and more symbols to communicate the same thing that you could do in fewer lines in C#. So for those of us that were ready to make that transition to something that was more streamlined and what we would call more elegant in terms of how you write your code, that's why we made that switch from Visual Basic to C#. So my first review on .NET, July 7, 2002, right? I read this book called Applied Microsoft .NET Framework Programming by Jeffrey Richter. And what that book did is it showed how much of C# and .NET at the time was defined in C++. So Jeffrey Richter pulled back the curtain on how .NET was implemented underneath so that you could gain greater insight. This was the start of my journey towards systems level programming, where I wanted to understand more about computer architecture. It was this book that did it. So if you watch any of my videos on other platforms or my other channel where I talk about different ways of doing software development, it was books like this and people like this that influenced that, right? And so, yeah, 2002 was when I wrote this review on .NET. So I have been using .NET pretty much since somewhere around October of 2001, and I was getting ready for the new generation that was rolling out. And I had a project with a customer that they brought me in on, and I said, hey, let's use .NET. It hadn't been released at that time, so I was trying to make the case for .NET with this customer somewhere in the fall of 2001. So I said, what better way to convince them than to actually build something in .NET? Build the solution that they are trying to put together. Because what they were doing, they were trying to use mainframe knowledge to implement a system in Windows, a server-based system to do batch file processing using Visual Basic technologies. And it wasn't working out for them. So I said, hey, let's bring in this more enterprise-grade technology that Microsoft has defined. And I didn't mention the part about how it was, pretty much a mirror of Java, right? That was not relevant to the conversation. What was more impactful was that this was a well thought out software development platform, and you had all the bits and pieces that you could use to build anything that you want. So by them investing in me and investing in this journey to implement this solution in .NET, they would be able to actually address many software development projects that they would have coming up in the future. So I was able to start my .NET journey concurrent with the official release of .NET in January of 2002. So here we are as of 2022, you're looking at 20 years. Now, the person in this particular discussion, they said that February 14th was the official release of .NET. That's actually incorrect. I know this is on a Microsoft website, but I will prove that the actual release of .NET is a month earlier than that. And so if you look at the history of C Sharp, right, you're up to the 13th version of C Sharp. That's the version that I'm using now, right? And so you look at version 1, released January 2002, right? And looked a lot like Java. And there's a deeper story about that, as you may very well learn if you dig deep enough. But and I could tell that story, but this is not the place for that. But you have version 1 of C Sharp, right? And you have all the different versions of C Sharp. Notice C Sharp version 5 released August 2012. And the thing about these different versions of C Sharp is that by and large, they roughly follow the .NET version, right? But here's the thing. By the time that you got to version 8, right? Version 7 and version 8, you are switching into what's called .NET Core. So that's what confuses some people, is because they hear these different .NET terms, .NET Framework, .NET Core, and .NET. So .NET Framework is the rebranding of .NET that Microsoft has assigned to all the .NET technologies from .NET 1.0 in 2002 all the way to .NET 4.8, right? And so .NET 4.8, let's see if we got a time frame on that. I believe .NET 4.8 was released in 2002. It may have been 2020, but suffice it to say, yeah, I believe it's going to be 2020 for .NET 4.8. But that is .NET Framework refers to that style of .NET, that way of .NET that Microsoft put together that is Windows specific. .NET Framework is the old Windows specific .NET, and it maxed out at .NET 4.8. But this is where the confusion starts, because then you end up with what's called .NET Core. So .NET Core was released somewhere around 2015, 2016, somewhere in that neighborhood, right? And the thing with .NET Core is Microsoft wanted to start over in how they did .NET, how they put it together for software developers to use, because they didn't want a Windows-specific .NET, because in order to run .NET in the cloud, you're not running Windows in the cloud, right? When you do all those cloud servers, like you got at Facebook and Amazon and Google, where you got hundreds of thousands and in some cases millions of servers that are running, that infrastructure runs on an operating system known as Linux. And .NET Framework was not designed for Linux. There's a very deep story about that. Maybe I will tell it at some point. But .NET had to be redone so that it could run on Linux, so that you could have an Azure cloud. And so that's what the reboot of .NET was all about, fundamentally. And that's why you don't have as much of an emphasis in the rebooted .NET on desktop programming. That's all maxed out in the .NET Framework arena for Windows, right? And so you have .NET Core, and then they went .NET Core 1, .NET Core 2, .NET Core 3. And then they said, okay, it no longer makes any sense for us to call this .NET Core. Let's just call this .NET. But that kind of perpetuated the confusion a little bit more, because what you end up doing is you skipped a couple of levels, right? So then you got .NET 7, right? So you got .NET 5. So they started over with .NET 5. So you got .NET 5, and then you got .NET 6, right? And then you got .NET 7, and now .NET 8, and now we're on .NET 9. I'm on .NET 9 and C# 13. C# 13 is the latest version of C#, and the C# versions generally get released with the new versions of .NET. So by my accounting, let's say it's an informal accounting, right? Informally, you're on the 13th generation of .NET at this moment. The 13th generation of .NET, right? But for purposes of keeping in alignment with the way Microsoft has described this, it's .NET 9. So .NET 9 with C# 13, right? And so the thing of it is that you have a long history with .NET now, right? So you have pretty much 22 to 23 years with .NET. I have 23 years with .NET because I've been using it since it was in beta, right? But yeah, you have multiple versions of .NET. And the thing to know about these versions of .NET is that, you know, as the time progresses, the terminology for the previous versions become less important. So what I did in my career, in my journey with .NET, is I stayed with .NET 4, 4.8. I maxed out on .NET 4.8. And then I saw the writing on the wall, because if you have any experience with Microsoft whatsoever, you know that they have a very strong track record of making technologies obsolete as quickly as they introduce them. Silverlight, for example, was going to be this next generation way of doing web development. It's totally gone. Now, its spiritual successor is Blazor with WebAssembly. So that's the spiritual successor of Silverlight. But Silverlight, in the way that it was defined, totally gone, totally defunct. And I know some organizations that still use Silverlight to this day, and it's totally unsupported. So I was like, I know what they're doing with .NET Core. I'm not going through that treadmill of them trying to figure this out, because you got all that rough stuff where if you do a technology too early, then there's some times where if you do something too early with this technology, that you build up muscle memory on that early stuff, so that by the time it gets figured out and settled, then your mind is fighting against those early foundations, right? And so that's why I said, okay, I'm gonna wait this one out. So I waited out the whole .NET Core thing, and I just stayed with .NET Framework, and then I jumped back in on .NET 6. So I said, okay, we got .NET 6, we got .NET 7. Let's work with that. Let's tiptoe into that. And then by .NET 8, I was really going into it, and now I'm all in with it with .NET 9. So I see some very interesting aspects with .NET on Linux, more than what has been discussed, I think, anywhere. And I'm going to bring that up in a future video. And if I am right about what I'm going to present, it's going to be pretty mind-blowing, right? And the tools are all there, but it's how you put it together. And the thing about .NET is that I took a parallel journey. So I did Microsoft .NET, right? I dabbled in Java a little bit way back when and along the way, but I pretty much stayed mainly with .NET. And then at the same time, I have a parallel course that I did. So I did both of these at the same time. Here I did Linux and C++ and C and Bash and all of that. So I became dual skilled, right? So I'm dual skilled in Microsoft world and Linux world, right? So previously, this was all Windows, right? And this was all Linux, and they were completely separate. But when Microsoft started acquiring GitHub, and they started doing Windows services for Linux and all that, guess what? They started to come together. So now it's like I made the right bet on Linux, and I am glad I invested in .NET because here's the thing. .NET gives you a level of productivity that is important in writing software where you want that software to also be reliable, structured, and somewhat deterministic in how you use it, right? And so I see many optimistic directions for .NET. And so if you found this part of the discussion interesting, let me show you something else that I've been doing with this process. I have a program that I wrote in .NET on Linux. I wrote it by hand. And basically what it does is it provides an informal stress test of the system. It's what I call a very informal stress test of the system. I also have a C++ version as well. So what I want to do is I want to show you something that I found interesting about C# on Linux. So this is very, very straightforward. We're just going to do a couple of what I call cycles. So what a cycle is a cycle encompasses all the instructions that you want to run within that cycle. So so to say it a different way, here a cycle refers to a second. So each second that passes, how much work can we do each second that passes, right? So let's go ahead and do like 1,000 of these and just let it run. Well, actually, I won't. Let's just do 700. So let's do 700 of these because I believe that if I do 1,000, it's going to take like 15 minutes. So let's just do 700 so that we can shorten this a little bit. And then while this runs, I'm also going to show you something else. So let's run the C# version and let's run the C++ version at the same time. Now you notice that starting out, that they basically iterate in a somewhat equivalent time frame, right? And so the cycle that they're on, right, are roughly the same. I did start the C# version slightly earlier than the C++ version by about half a second. So that's where you see that differential there. But what is more interesting is if you look at each cycle, right, and the number of iterations that we do per cycle, in the C# version, we are averaging about 250 million iterations per second. In the C++ version, we are averaging about 13 million. So there are more iterations accomplished in the C# version than in the C++ version. Now, you may be asking the question, what is going on in the C# version and the C++ version? So this is still going to run for a little bit. So while we're waiting on that, let's take a look at what's going on with let's look at the source code and see what we can understand about this. So this is the project that I built in .NET on Linux. I did it all on the command line, so I didn't use VS Code. I have other videos out there on the internet that explains the rationale for doing command line based development. There's nothing wrong with VS Code or Visual Studio, but I think there are some advantages where you become very proficient with the command line. So let's open this up. I'm going to just go ahead and delete these directories here. Those include our binaries, or they did, but now no more. Let's see. So we'll just build this. So by default, it's going to build a debug version. So let's also build a release version as well. It's the release version that I'm actually running. So I'm running the release version, and then that's what's actually executing, right? As far as the source code, it is very simple program, right? I wrote this by hand, 23 years of experience with this. You know, this is just basically done from memory, right? In terms of knowing the APIs, knowing, what functions to call. A much more complicated program than this, then yeah, so I still have, even after all that time, I still have to look at reference manuals, right? But there are many things that I've done where it's like, okay, I don't need to do that. So anyway, basically, you have a general outer loop, and one of the things that I do is I synchronize this to the system clock, and I want this, if at all possible, to run on what I call the zeroth boundaries of time, right? So if it is 3:04 and 53 seconds, I want to wait out until we get to the top of the minute, right? So instead of 3:04, I want to run at 3:05, right? Or if it's 3:05 and 13 seconds, I want to wait until 3:05 and 20 seconds, right? So that's how this is set up to make sure everything is aligned appropriately, right? And so then the actual work that's being done is done here. It's very simple, and it has a couple of things that it's doing. It's doing some math operations. So it's doing a couple of math operations here. It's using modulus, right? It's doing increment, and we're also doing equality comparison. We are invoking a object, right? So there's heap access. So we got stack and heap access, right? Notice that I'm using a native unsigned integer. So that's going to prevent integer overflow if we decide to run this for 1,000,000 iterations, right? And so, yeah, so it's pretty straightforward what this does, right? And then we have the C++ version, right? And I'm actually going to obliterate all of its stuff. So let's close that out. And just compiling it is pretty simple. I ain't came up with a better word yet, so I just called it timer, right? And you can actually do all kinds of flags and everything, but I wanted to do something more default with the way I compile this. You could do, I believe, 03 fast or something like that. I have it in a script somewhere. Loop unrolling, and you can do machine architecture equal to x86-64 or something like that. But anyway, the C++ version, let's take a look at it. Now the C++ version, I wanted it to have, I wanted it to match the C# version in terms of how everything is laid out to the screen. And so while I wrote the C# version by hand, right, I said, okay, this is where we can use AI. So I used ChatGPT 01 and I said, hey, take this C# file, and I program my ChatGPT instance. It has very specific standards, and I said um, I want you to go and make an exact version of this in C++, because AI is pretty good at that sort of thing, right? It's not going to build a program from scratch, but if you have a quality program that you know works, then you can have it just replicate that program in a different language. So here I'm using unsigned int fast32t so that we have the fastest integer for the platform, and it will vary between 32 bits or 64 bits depending on what's going to be fastest for the implementation. I have some custom format functions. It's actually much more verbose than the C# version in terms of what it does for doing the exact same thing. It's far more verbose. So this is the code that has to be written in C++ unless you are using some third-party libraries. But this uses the standard template library, the STL. And I made some optimizations beyond what ChatGPT was able to do. I actually introduced this. I wrote this. I have a formatting function here because it wasn't formatting things properly. I did some optimization here with the buffer. I just wanted it to output a certain way, and so I had it correspond to the way I was doing the buffers here with the string builder instances. So, long story short, I have identical implementations, one for C# and one for C++. And what I observed, accounting for the synchronization, the time synchronization, even when I take the time synchronization away, the number of iterations per second does not deviate significantly. And so, unless there's some other factor that I have not accounted for, and I am willing to say that there's another factor I haven't accounted for, the C# version on Linux, pretty much out of the box, even with the release flag, pretty much out of the box, because actually the debug version runs somewhat similarly. It runs faster than the C++ version. You can calculate more per second with the C# version over the C++ version. You can do some things in C++ to have it totally take the speed crown. But that's not the point, is it? The point is to be able to use high-level abstractions, because that's the whole direction of C++ 11, C++ 14, C++ 17, C++ 20, C++ 23. The whole direction of the new C++ is to write everything high level, use smart pointers, and in fact, in this case, I don't use pointers at all, and to basically do things in C++ the same way in terms of concept, in terms of ideology, the way you would do it in Java, C#, Swift, TypeScript, and dare I say, Python. And so here's our result. They finished exactly the same time with just a slight variation in the milliseconds. So the C# version was only 722 milliseconds faster. That's it. Not huge. So you don't have a huge difference in performance. The performance is equivalent. And the thing is that for me, this exercise completely destroyed the idea that C++ is going to be faster out of the box in all cases. I'm talking about the compiler. I'm not talking about the language. But if my implementation is correct, then this means that there is some work to do with the GCC compiler on Linux Maybe clang would be different, right? I haven't checked to see if I have clang. Let me see. Do I have clang? I don't remember if I installed that. Oh, I do have clang. So let me see if I were to redo this. So if I were to take this and I was let's say, it's been a while since I used clang on the command line, so this might actually error out, but I'm going to try it anyway. And if it errors out, I'll just investigate independently. All right, let's see. Okay, so while I'm here, let's see if clang, remember I did 700 iterations. Let's see if there's, nope, no difference. So even with clang, we're still averaging about 12 million iterations per cycle or per second, just on average. So let me go ahead and stop that. So this has been eye-opening for me. But yeah, so this gives me confidence in .NET in the Linux environment, in the server environment, of .NET for scripting, you know, because some of us we can write C# as fast, if not faster, as somebody writing Python. So for just doing ad hoc file utilities, ad hoc scripting tasks in Linux, C# would be much more competent for introducing structure, class libraries, and having process around it, but not doing it in such a way where it also slows you down significantly, right? So there's a better balance there. We're talking about the whole conversation around Rust, right? You want memory safety. You got memory safety in C#. So C#, if it continues to evolve the right way, it could replace C++ on in the Linux environment. And I have a surprise that I'm working on. I have something I'm working on. It would be a surprise if I told people about it, but there's something I'm working on in private um, that um, that I'm very excited about if it works. And if it works, then it's pretty much the the not game over, but it's like it's the whole enchilada in terms of being able to use .NET on Linux and do it in a way that um, achieves many of the goals of software development, where you want a long-term direction and assuming there's no embrace, enhance, and extinguish kind of situation going on in the future, then it could actually turn out to be a very, very good deal. So this is what I wanted to share today. I hope you found this useful. And until I see you again, I will see you on the next one. Bye-bye.